Module 7 is about hypothesis testing. Basically, in statistics, hypothesis claim about something, and it could be anything about a population. So somebody's making a claim, and the hypothesis test is the process of testing that claim. Quick warning is that the hypothesis testing, the terminology gets a little bit technical, but it's not all that bad. So I recommend that you read through the lecture notes along with watching this video. So I'm going to highlight a few of the components you will need to do a hypothesis testing. The first one is the null hypothesis. It's typically written as H0, and it's a statement about that the value of the population parameter is equal to some claimed value. So at the end of the day, what we'll do in the hypothesis testing is we either reject the null hypothesis, whatever that statement is, or we fail to reject the null hypothesis. And I'll show you what that means in examples later. So the alternative to the null hypothesis, called it alternative hypothesis, it's typically written as H1 or HA, is a statement about the statement that the parameter has a value that's somehow different. So meaning not equal to or less than or greater than from the null hypothesis. So the next in the process is you calculate the test statistic, typically the z-value, to make a decision about the null hypothesis. And there are a couple ways to make a decision about whether you reject or not reject the null hypothesis. And some of the words you might read in the lecture notes is critical value, critical region, but the one we're going to use is the p-value. But before we get there, you have to know one thing, the significance level, which is denoted by alpha. And it's a probability that the statistic will fall in the critical region when the null hypothesis is actually true. So for you, what that means is that typically alpha value is 0.05, 0.01, or 0.10, which equates to 5%, 1%, or 10%. So what we do with the significance level is that in the next process, we calculate what we call the p-value to determine whether to reject the null hypothesis or not. So how the null hypothesis is rejected if the p-value is very small, or such as less than 0.05, or it falls in the critical region. And just a quick note is that the p-value here is not the same as a probability or proportion. So we'll be using the significance level, p-value, and test statistic to figure out whether to reject or not reject the null hypothesis. There are a couple different types of hypothesis tests. One is the left tail, when we want to determine if the parameter, whatever the parameter is, less than the predetermined value. Or we use a right tail test when the parameter is greater than the predetermined value. And we use the two-tail test when we have no idea if something's less than or greater than to a predetermined value. So that's the case, we use the two-tail test. So here's a general procedure for hypothesis test. This is going to be the same for any type of test you will do, whether in this module or the next module. First thing you want to do is you want to set up the null hypothesis and the alternative hypothesis. And I'll show you how to do that. And determine the alpha. Typically it's going to be 0.01 or 0.05. And then you have to figure out whether you have a one-tail or two-tail test to use. For this class, the alpha will be given to you, so it's typically 0.05. And the next step is to determine the test, typically the z-test, and calculate the appropriate test statistic. Again, it's going to be either z or t. And lastly, determine whether the test statistic falls in the critical region, meaning that if the p-value is less than alpha, reject the null hypothesis. Otherwise, do not reject the null hypothesis. So it's worth memorizing this rule where it says if p-value is less than alpha, reject the null. Otherwise, do not reject the null. We'll use that test. We'll use that rule to figure out whether to reject the null or not. So it's probably easier to see what I'm talking about in an example. So let's go to the first example. So here, imagine there's a new drug, and the drug company is claiming that the drug will enable gender selection for the newborns. The company claims that with the new drug, among 726 babies born to parents who attempted to have a girl, there were 668 girls, and then the rest were boys. Without the drugs, you expect to have a 50% chance of having a girl. So say alpha is 0.05. You want to test the claim that with the drug, the proportion of having a girl is greater than 0.5, meaning that does the drug work as advertised? If the mom takes this drug, does she have a better chance in having a girl? So first, this is a claim about the proportion, and in this class we'll be testing the claim about the proportion or the mean. So this problem is a proportion because the problem says so. So like I mentioned, the first step you have to figure out is figure out the null hypothesis and alternative hypothesis. So I'm using the p here as proportion. So the p is 0.5, meaning that that's the status quo. Without any drugs, I expect to have a 50% chance of a girl. Alternatively, the drug company is claiming that with the drug, you have a better chance of having a girl. So it's going to be better than 50% chance. So it's greater than here, and this is a one-tailed test because it's a greater than. So the n is 726 from the 726 babies here. The p hat is going to be 668 divided by 726 babies. That's the proportion p hat. The proportion, population proportion, you expect it to be 50%. So that makes the q also 50%. So I'm going to use the test z-test here. So following this formula where it's in the lecture notes, 0.920, which is from here, minus 0.5, which is here, divided by square root of this times this, divided by the n. So that's why I did that in this cell right here. So that z is 22.63, and here's where you use a normal distribution, norm.s, this function. But one thing you have to remember in this particular problem is that we did the greater than test. So just like in module 5 and 6, since it's greater and then Excel expects the less than scenario, we'll do the 1 minus business here. So 1 minus probability of z is less than 22.64. And when I calculate that value, I get the value of 0.00. Okay, so that's your p-value. So now what you do is compare this value, 0.05, to 0.05. So if you think for a minute, 0.00, is that less than or greater than the alpha, which was 0.05? So in this case, 0.05 is less than, or 0.00 is less than 0.05. So that means the rule says we reject the null hypothesis. So what that means in the context of this problem is that the drug does seem to have an effect of producing a preferred sex of the baby, in this case the baby girl. So that's the general process of how you go about doing the hypothesis testing. So let's look at the mean, testing the claim about something about the mean. So imagine a boat company who needs to accurately estimate the mean weight of the passengers on each boat. It collects a sample of 40 passengers and then found that the sample mean is 172.55 pounds. Assuming that the sigma is 26 pounds, figure out or test the claim that the mean weight of the men is less than 166.3 pounds. That's the Boating Association's claim. And again, the alpha is given to you as 0.05. So, just like the last problem, I set up the null hypothesis and alternative hypothesis. So the null, again, is always going to be the status quo, so it's always going to be equal to some number. And in this case, the claim is 166.3, so that's the number you make it equal to. And the claim is that it's going to be less than that number, so that's why it's less than here. So it's going to be a one-tailed test. So n is 40, the mu is 166.3. The sample mean, x bar, is going to be 172.55 pounds. And the sigma is given to you. So from the lecture notes, you know that to figure out the z for the hypothesis test for the means, the formula says x bar minus mu divided by sigma divided by square root of n. So I put those numbers, these are the numbers I'm using. And that's what I did in this cell. So again, I'm going to use a normal distribution. So norm.s.this function, and I don't have to do the 1 minus business because it's already less than. So this is my p-value. So again, we compare the p-value 0.9358 to 0.05. Since 0.9358 is greater than 0.05, we cannot reject the null hypothesis. What that means is there's not sufficient evidence to support the conclusion that the population weight is less than 166.3 pounds as the association claims. You should remember that we cannot confirm that the mean weight is greater than 166.3 pounds. We can only reject that conclusion. So that's the shortfall of a hypothesis test. We cannot be for sure 100%. Some people get a little bit confused about what does this means. Well, if you think of a situation where somebody is found guilty, we don't know for sure if the person did the crime or not 100%. The evidence shows that he's more likely than not that he committed the crime, but we can never be 100% sure that he did or he did not commit the crime. So that's similar to here. We cannot say that the mean weight is greater than 166.3 pounds. We can only reject that conclusion. So in this class, we'll be seeing the problems about the proportion or the means, and this is how you do mean hypothesis testing for mean. Lastly, sometimes you have no idea where the situation is less than or greater than. We just know that the amount is equal to, or amount is not equal to some number. So for example, imagine you're like accountant for a small firm. Your task is to determine whether the mean amount per sales invoice is unchanged from $120 during the past 5 years. Since you're an accountant, it is your job to determine whether the mean amount per sales is going up or down. So let's say you have no idea if it's going up or down, but you just know the mean amount of sales per sales invoice is possibly changed from 120 pounds. So in this case, you assume the mean is the same as 120 pounds. Alternatively, since you don't know if it's going up or down, you just say, okay, I have no idea, but I know it's not going to be the same as 120 pounds. So you make it equal to, or you make it not equal to 120 pounds. That's what it makes a two-tailed test, because we don't know if the amount increased or decreased, but we want to know whether it changed. So this is how you set up the null hypothesis and alternative hypothesis in case if you don't know if it's greater or less than. And this problem follows the t distribution. And we use a t distribution again if we don't know the population standard deviation. In this problem, you do not know that. So you calculate your own sample mean and your own sample standard deviation of $20.80. So if that's the case, you use a t-test. And this is how you do it here. Again, you calculate the p-value, and the critical value is p-value is 0.06. Since it's greater than 0.05, we cannot reject the null hypothesis. That means there's not sufficient evidence to support the conclusion that the mean amount of invoice is changed over the years. So it looks like the mean amount of invoice over the last few years remained as at $120. So that's how you conclude this kind of problem. So now you know how to do hypothesis testing for proportions, means, and using t-distribution.